Today we're going to talk about separations, which is fascinating because what separations enables us to do is to take a mixture of substances and separate them into their components. This is possible as long as we have one property between the two compounds that is different. If we have one thing that is different between these two compounds, that means that I can manipulate that one property until I can separate the two things into different boxes. Okay, now, usually separations occur in tiers, so you'll do a big bulk separation of a whole bunch of stuff, and then you'll do another little mini bulk separation. And then you'll get down to where you're separating very, very fine things into maybe just a solvent and a solute system where you can evaporate the solvent off and you'll be left with the one thing that you want. So today, we're going to take a mixture of sand and salt, which is what I've got in here. Pure sand and salt, table salt, so sodium chloride, and just sand from out at a beach, except clean because we buy it. We want to figure out how much of this is sand and how much of this sample is salt. Percent by weight, so that means we want the mass of the salt divided by the mass of the mixture and the mass of the sand divided by the mass of the mixture times 100, okay? To do this separation, what's great about this is that salt dissolves in water, but sand doesn't. We've all been to the beach, well, maybe you haven't, but we've all seen pictures of beaches where sand exists against water, so we know that sand is not going to dissolve, okay? But the water is salty, so we know the salt will dissolve. So what we're going to do is I have taken this beaker and I have obtained its mass, and then I have put a sample of our salt and sand mixture in it, and I have obtained the mass of the mixture plus the beaker. The mass of the mixture in the beaker minus the mass of the beaker will give you the mass of the mixture, the original mixture. Now, to do the separation, since we're going to be manipulating solubility, we need to be able to separate a liquid from a solid at that point because the sand will be solid and the salt will be in an aqueous solution or a water-dissolved solution. To do that, I'm going to need quite a bit of equipment. I'm going to need deionized water in a bottle ready to squirt. Okay? I'm going to need an iron ring stand with an iron ring. The iron ring is too large, so I'm also going to need something called a clay triangle. It's called a clay triangle because these little bits right here are clay, and they're in a triangle, okay? We're also going to need a funnel. We're going to need an evaporating dish to catch the liquid. Notice it's just a bowl that has a spout on it, but it's very shallow, and it's made of ceramic, which means that I can heat this really hot to maybe dry off something that takes really high temperatures to dry. Okay, we're gonna need a couple of stir rods. We're gonna need a scoopula. We're going to need at least one watch glass and at least one piece of filter paper. Okay, we're also going to obtain the mass of the watch glass and the filter paper together and separately. That's going to help us with some of our calculations at the end. So I'm going to go get those masses, and then I'm going to show you how to set up this. Actually, let's show you how to set up that contraption first. So let's turn around here. Okay. I need a method. Once I've got my salt and sand dissolved in water, I need to filter off that liquid and hold back the solid. So what I'm going to use is a funnel. I can pour liquids and solids into a funnel, and it will hold them. Except I'm holding on to it, so that's not good. And I need something for the liquid to go in, so I need to do a little bit of work here. So I'm going to put the funnel into, it's going to go into my evaporating dish. But now I'm stuck holding this, and that's not very good either. So I need something to support this funnel for me. So I've got my iron ring and my iron ring stand, so why not use the iron ring to do it? I'm going to attach my iron ring, lower it down, clamp it into place. There we go. And then now I can just sit that right there, and that's not very stable. So I can do better. I can use a clay triangle. I can put the clay triangle on top of the iron ring, and it makes the hole smaller so that my filter, my funnel, is suspended. Now I need to lower the funnel into the evaporating dish. I want the cut edge of the funnel to be pushed against the side of the evaporating dish, and I want it to be about 2/3 the way up the side of the evaporating dish. So I've got to lower this down, way further down. About right there will get me there. And then I'm going to push this to the side itself. We're doing that because we want the drops that come out of the funnel to not drip and splash. We want them to gently flow down the side of the funnel, or of the evaporating dish. So now, there's schmutz in my evaporating dish. Now, if I just need to pour, but that's not going to work, is it? Okay. So instead, I'm going to take a piece of filter paper and put that right on top like that, and then now I can just, but the water's just going to go everywhere. So I need to actually prepare this filter paper in some kind of way that's going to allow me to put it into the filter. So the method we're going to use is that we're going to fold this filter paper. Now, there are hundreds of techniques for folding filter paper. Each one has a very specialized use, and each one is perfect and amazing in its own way. All of them are really difficult. And we don't need complicated right now. We just need this to fit into that funnel. So we're going to use the easiest one, which is to fold the filter paper in half by the diameter. Okay, and then fold it in half one more time so that we have this conical shape. Now, you'll see that there are 3 edges that are facing you, or excuse me, 4 edges that are facing you, right? I'm going to gather 3 of them together and 1 of them separate so that I push it out like a snow cone or a raspas cone. Okay, that you would get at like a baseball game, like a little league baseball game, not the good ones, but the the cheap ones. Okay, now this is ready to fit into my funnel, but it's not sitting very well in there. Okay, so what I'm going to do is I'm going to take my funnel out and I'm going to use just a little bit of deionized water, and I'm going to do what's called wetting the filter paper. Wet paper sticks to glass really, really well, okay? So by just making the filter paper itself a little damp, it's now adhered to the funnel, and I've got a little bit more stability out of this. So now I'm ready. I can start my process. Now, while I was gone, I got on the rest of my personal protective equipment: goggles to protect the eyeballs, gloves to protect the hands, and my lab coat to protect the rest of me. Okay? I also obtained the mass of the evaporating dish, the watch glass, and the filter paper. You will be glad you did this later on. Okay? So I'm going to start by, again, preparing my filter paper by folding it in half down the diameter, and then in half so that I get my cone. I'm going to gather 3 of the 4 edges together, form a little paper cone, place it into the funnel, and use just a little deionized water to adhere it to the funnel itself. Okay? Now, put it back down here. Place the funnel sitting against the edge of the evaporating dish about 2/3 of the way down. Okay? And now we're ready to actually start chemistry. Okay? So I've got my mixture of salt and sand here, and remember, the salt is soluble in water. It will dissolve in the water, but the sand will not. So what I need to do is use the least amount of water possible to dissolve all of the salt that's in here. I don't want to have to dry off a whole bunch of extra water later because water is very difficult to dry off. So what I'm going to do is I'm going to use small amounts of DI water just from my normal DI water container. And as I'm doing that, I'm going to use a stir rod to mix the two substances, or the three substances actually, together. Now, this water looks really, really cloudy. So that tells me that my sodium chloride has not all dissolved, because I should get a nice, pretty, clear, colorless solution. So that means I need to add a little bit more water. I'm going to continue doing this and mixing it until you don't want more than about 10, 15 at the most mLs of water in here. And I'm at about 5-ish right now just by eyeballing it. So I can still add a little more, and I need to. The water's still cloudy. Okay. We're going to keep mixing here. And now that I think I've got enough water in here, I'm going to mix this for a good 2 minutes. We want to really make sure that we're giving that salt time to dissolve completely. Now, the reason I'm going to continue mixing it like this is that I want to be sure that the water is in full contact with the salt. So the only way to ensure that is to continuously mix it with my stir rod. Now, one other way of knowing that this is done is that sand has a vaguely beige color and salt is a white crystal. So if I look in here and I see any white crystals rather than beige miscellaneous shapes, I probably need to add a little bit more water. But right now, this looks really good. So I've prepared my funnel and I'm ready to go. But that sand really wants to sit on the bottom of my container. So to get it out, I'm going to give it a good swirling as I pour it onto my filter. Now, there is lots of sand left in there. How do I possibly get that sand out of here? Well, luckily, I've still got a little DI water sitting here. So what I can do is tilt this upward and use just a little bit of extra water to rinse any of that excess sand into my filter. Now, make sure that your liquid never goes above the height of your filter paper, and make sure that you give it one last thorough washing to get all of the residual salt that's on the side of the container out. Now, at this point, it's a waiting game. You'll notice that it's slow. This is gravity filtration. And while gravity feels strong to us, it's a little slow on everything else. So we're going to allow this to sit here and drain fully. We want to see no standing liquid on our filter paper up here. The filter paper will still be damp, but we don't want any standing liquid. So we've given this about 5–10 minutes. That's enough time for it to drain completely. You'll notice that there are no drops trying to form down here, that there's no water puddled up top here, and that our evaporating dish, I'm going to tilt this down, is a little less than halfway full. That's perfect. We want it that low. If you have more liquid in yours, that's fine. As you can see, we've got about half full in our evaporating dish. We call this substance the mother liquor. We call the solid the filtrate. If you are taking 1411, we're going to talk about how to dry this down at the end of the video. If you're taking 1405 or 1411, we're going to talk about how to dry this down in just a moment. So we now have a wet sand thing going on in here. And if I want to know how much sand there is, I have got to get rid of that water. So the way I'm going to do that is I need to gently heat this, but I still need to get it very, very hot. You could put this in a fire, but I don't think that's going to end well for you. You'll catch your paper on fire, and you might not be able to collect your sand at the end. So what we're going to use is called a hot plate. And this is just like a hot plate that you would buy at your house, except it gets much hotter. And it has one other feature, which is called stirring. We're not really going to deal with that, so don't worry about it. The way a hot plate works is that there's an electrical element, just like if you had an electric oven or an electric stovetop, and it heats a piece of porcelain, which is what's on top here. It has a control, and a temperature readout. So we're going to turn this temperature readout. Water boils at 100 degrees Celsius, and this is given in degrees Celsius. So we want our temperature to be higher than that, but we don't want to burn paper. And remember, that's 451 Fahrenheit. So we need to be lower than that in Celsius, and you do the math, okay? Now, how do I actually do that? Well, you've got a nice little package here. You can just slide your packet of sand off of the funnel and then sort of fold it in half along those lines that you've already folded down. Now, this is ready to warm up. Put it just one side down directly onto the hot plate. This is going to take a minute because it is water and it does take time for water to dry. So just leave it sitting there. You're going to see some steam come off of it. That's normal because it's water and it needs to have steam for it to cool, for it to heat up and dry that water down. You'll know that this is done because the sand will start to freely flow inside and it will sort of slump down. Okay, if not, wait until the paper is crunchy but not burned. We want to make sure that we never burn our paper because that changes the mass of the filter paper, and we're going to weigh this in the filter paper so that we don't lose any. So it's just a waiting game. So let's wait. We've waited. It's dry. I'm not going to show you this, but we are going to then take this filter paper with the sand, place it, take it gently off using a set of crucible tongs, and put it onto our watch glass to cool down to room temperature. At that point, we're free to obtain the mass of the watch glass, the filter paper, and the sand. The mass of the watch glass, the filter paper, and the sand, minus the mass of the watch glass and the filter paper, is equal to the mass of the sand. The mass of the sand divided by the mass of the mixture times 100 tells you what percentage of sand you had in your mixture. Okay, now for those of you who are required to dry your salt down as well, I'm going to show you how to do that. To do that, we need fire. We need something hotter than a hot plate. We need something that's going to really get the heat flowing. So we're going to use a Bunsen burner for this. So for this setup, we're going to need a clay triangle, a ring stand with an iron ring, a Bunsen burner, your evaporating dish with your sample, and you're going to need a set of crucible tongs at the end as well as a wire gauze to cool this on. So first thing we're going to do is we need to set up our Bunsen burner. So I'm going to move everything to a safe location away from my Bunsen burner because I don't want fire on anything else. And remember to safely use the Bunsen burner. We've got the bell and we've got the gas inlet. We're going to close both of those off completely. and then we're going to turn both of them 2 big turns. Once we've done that, we're going to connect this to our gas line, and now we're ready to introduce fire to the situation. So you can use a striker, you can use a match, you can use another Bunsen burner. I'm going to use a match in this case. So you strike your match, you make sure it's good and going, and you're going to hold it slightly off to the side. You don't want to hold it directly over your Bunsen burner. Then you're going to turn on your gas with gusto. Don't be afraid of it. Lean back, but don't be afraid. You don't want to lose your eyebrows. Okay? Now, as you can see, we now have a wonderfully lit fire. Okay? So, to perfect this, I'm going to close down the gas just a little bit to give us a little bit more stability, and I'm going to open the air a little bit and completely lose my fire. This is more art than science. Don't be afraid if a Bunsen burner takes you 2 or 3 tries to light. It's okay. It's fine. Look at that beautiful, stable 2 blue cones of flame. There you go. You can see the inner blue cone and the outer blue cone. The inner blue cone is most definitely the hottest part of this fire. It's the hottest part of any fire. We don't need that much. We're just trying to boil water. So what we're going to do is we're going to put our evaporating dish a little bit above the outer blue cone. That's going to be more than hot enough to boil our water. The other thing is we need to gently heat our water. We don't want popping and fizzing, because every time a bubble pops, some of the salt gets thrown out of our solution. So we need to do this as gently as possible. Okay? So now I'm ready to set up the rest of my setup. I'm going to take my ring stand and iron ring. I'm going to raise my iron ring all the way to the top. I'm going to put my fire on the ring stand, and then I'm going to lower my iron ring so that the outer blue cone is just a little bit inside of it. Okay? Now, my evaporating dish won't set on that iron ring, so we're going to use the same fix that we used earlier. We're going to put a clay triangle on here, and then we are going to gently set our evaporating dish on top of that. Now, this is probably a little too close. It was too hot for my hand, so we're going to move that up some. And we want this to evaporate, not boil. So if it gets too hot and it starts bubbling and boiling, we're going to remove the heat and we're going to allow it to cool down. Then we can put the heat back on, or we can raise the level, or whatever we need to do. This will take time. It can take 30 to 45 minutes, depending on how much water you have in your solution. Once we're done with this, we're going to remove this from the heat. We're going to allow it to cool completely to room temperature. Once there is absolutely no water left in there, we're going to cool it all the way back down to room temperature, and then we're going to obtain the mass of the evaporating dish with the salt in it. The mass of the evaporating dish with the salt minus the mass of the evaporating dish gives you the mass of the salt. The mass of the salt divided by the mass of the original mixture times 100 equals the percent of salt in your original mixture. The percentage of sand plus the percentage of salt is called your percent recovery. That tells you how efficient you were at doing this exercise.